Now, we've done these in the past. We have done these almost exact problems in the past, so that's why we're going to start out with a little review, but we're about to enter a whole section on radicals, roots. So here we go. All right, let's do the variables first. No, you cannot. -4 comes out here by himself because he's right here, so he just stays out there. Who remembers how to do the letters on these? Anybody? No. No. Juri, how many groups of 5 can you break 10 into? 2. So I can bring out 2 M's. So if I took out 2 groups of 5, how many are left in there?
0.
None. Because 2 groups of 5 is 10, and there was only 10 in there in the first place. So all my M's are gone. What about my N's? How many groups of 5 can I break this into? And how many are left? Very good. What about this? 1. And how many are left of that? So this is an interesting problem because no M's, N's, or P's are left in there. Now if this had been a 6, for instance, on the end, and we took out 1 group of 5, then there'd be 1 left, because 6 minus 5 would be 1.
So where does the 2, 2, 4 go?
Well, that is where, I don't know if you remember this, but we have to do a prime factorization.
You don't remember it?
No, I said I don't know if you remember it. So, we're going to do a prime factorization of 224,
Can't you make it simpler?
and we're looking for a number that occurs how many times?
2, 1, 1.
5. We're looking for a number that occurs 5 times. So, here we go. 224. Let's see, if you punch that in the calculator, I think you get 28 and 8,
Yes.
2 and 4, 2 and 2, 4 and 7, 2 and 2. So our prime numbers at the bottom are 2, 2, 7, 2, 2, and 2. Does anything occur 5 times?
Yes.
What? And what does not occur 5 times? 7. Okay. So it means I'm going to pull a 2 out because it occurred 5 times. And the only thing that didn't, the 7, has to stay under our 5th root. So this is, well actually it's not quite our answer. We have to combine some stuff. But what's in blue right there is most of our answer. What is the only thing we have left to do? There's only one like term we can combine. Yeah, the -4 and the 2. What's -4 times 2? -8 m squared n times p times the 5th root of 7. We've done those before, but I had a feeling we'd be rusty on them, so I thought we'd start out. We're also going to have 1 or 2 of these on our assignment today, and then we're going to move on to the rest of the radicals. All right, the first one on the left. This one is just like the one we just did. So, here we go. I'm going to ask random people. First of all, the -2, what do we do with it? Yeah, just bring it down. Don't touch it at all. So I'm going to put this 5th root over here. We're going to take some stuff out, leave some stuff in. Ashley, you want to help me out to start out with? I believe in you. How many groups of 5 can you take out of 7? 1. That's very good. And if you took 1 group of 5 out of 7, how many are left? If you took 1 group of 5 out of 7, very good. Very, very good. Wyatt, what about the Y's? How many groups of 5 can I take out of 2? None. So they're all going to be left in there. Kennedy, how many groups of 5 can I take out of 8? 1. And how many are going to be left in? Very good. Letters are done. Now all we have to do is the prime factorization of the number 288.
Did we do this before?
Yes.
Where you do the coordinates? 8 and 36.
What I was asking them, Mark, was how many groups of 5 can I take out of 7?
Oh, I see where you're
And And then there's 2 left and one group of 5. Okay. What did you say? 8 and 36?
8 and 36.
All right, 8 and 36. 2 and 4. 2 and 2. We're looking for a number that occurs how many times? 6. I mean 5. Yeah, 5. And that'd be 3 and 3. Does any number occur 5 times on that bottom row?
Number 2.
2 does. Is there any number that does not occur 5 times?
3.
How many times does it occur?
2.
So I have to leave 2 3s in there, and I'll simplify that in a second. All right, can I erase that factorization tree? All right. Now we're ready to simplify, and there's only a little bit to do.
Well, we'll simplify with this -2 to the 2. -2 times 2 should be 2.
Very good. -2 times 2 is -4. X to the first, z to the first. And what's 3 squared?
3 squared.
Yeah, at the end of our radical here. 9. So it'd be 9.
X squared, Y squared, Z.
Very good. X squared, y squared, z cubed. Good. And you're right, actually, we did do this before, so I'm glad it's serving as a review for right now.
How can we take 5 out of a group of 5?
That's an excellent question. So why necessarily groups of 5? It all depends on your index right here. What is in the corner of the root? If that had been a cube, we'd only be taking out groups of 3.
We only got one of them for homework.
So why did you change your name before?
Anyone did
Did
it.
you say
Because you get how the 2 came out. Well, we already had a -2 out here. So we multiplied those and got -4. Other questions? Okay. Moving on. Let's see. All right. The next thing we're going to look at is the addition and subtraction. Addition and subtraction of roots. Now these are much simpler. However, you are going to have to reduce them similarly.
Can't you just punch it in?
No, I do not want decimals. You have to have these as roots. Now here's the thing. If they give you something like this, if they bother giving you something like this, you have to know the whole point of it is that at least 2 of them are going to have a common root, which would make them a like term that you can combine. Yes.
Just want to make you mad, but even if they're not in decimals on the test, can't you just like punch it in on the
Yeah,
calculator?
you could. I encourage you to take shortcuts like that. I wish people would have done more of that on the last test. Yes.
On number 2, how do you get the -4?
I'm not going to do evens right now. I'll do evens like toward the end when we're doing the list. All right, now, so the whole point of this, you better know at least one of these is going to break down into some kind of radical 3. Because if we had like 4 radical 3 minus 3 radical 3, they're like terms. 4 minus 3 would be 1 radical 3. So that's the whole point of problems like this, is to see if you can combine like terms and reduce your radicals. So what we need to do is try to break these 2 down. Now, there's going to be glaring hints in a lot of these problems. Like, I'm wondering if 3 doesn't break down out of this. If this thing doesn't break into 3. So I'm going to look and see if these things aren't divisible by 3. Is 27 divisible by 3?
See?
What does it break into? 9 and 3. Very good. Now, I could stop right there because, am I looking at square roots, cube roots, fourth roots? What am I looking at right here? What kind of roots are these? They're square roots. When there's no number in the index, you know it's a square root. Is 9 a perfect square? Yes, it is. I could rewrite this as negative the square root of 9 times the square root of 3. And what is the square root of 9? 3. That's correct. So that would be -3, because that comes into this, radical 3. And I've reduced that first one.
Yeah, I
understand what you're doing, but it's like a lot. It's really confusing.
A lot more.
27. Here's the thing. Any square rooted number, you could break down into the square root of 2 factors of that number. Like square root of 100, you could break down to the square root of 10, that's kind of the square root of 10. See what I'm saying by that?
Yeah.
So your goal in this, since these are square roots, we're looking to break it down into 2 square roots so that one of them is actually a perfect square. What is, you have calculators, what's the square root of 9? 3. And if you can actually take the square root of it, then you can get rid of the root and just call it 3. So this became -3 radical 3.
Okay.
Now the whole point of this, now look, let's pretend this second term wasn't here for a second. Now we have negative 3 radical 3, negative 3 radical 3. Those are like terms, and you can combine those, like 2x and 3x in the last step. That's the whole point of this, is to see if we can't condense this, or simplify is what I think it says in the directions. But before we go on to that, we have to do the middle term. Now we're hoping it breaks into radical 3. How does 18 factor with a 3?
6.
Is 6 a perfect square?
No.
No. Dang. So this is not going to be as pretty as the last one. Is there another way we can factor 18 to where one of its factors is a perfect square?
9 and 2.
9 and 2. That's exactly right. Which one of those is a perfect square? That's right. So this is minus radical 9 times radical 2. Tyler, what was the square root of 9?
3.
So I can make this 3 radical 2. Would you agree with that?
Yeah.
And then the last part is already, if the number under the radical is prime, there's nothing you can do with it. So the 3, this one's just going to come down as it is. Now,
I didn't understand a single piece of that.
which part?
Like, yeah, all of it.
You mean the thing I was just telling to Tyler?
Like the very beginning. Square root. Okay, I get that you get like 27 divided by 30, and you're trying to find the perfect square.
Mhm.
It's 9 30.
Okay.
And then it comes down to be 30 radical 30.
So you get that.
Yeah, I get that.
Same thing with 18.
Okay. There we go.
Okay. Now, ideally, the only reason, I probably lost you when I tried the 3 and the 6. The only reason we did that is because ideally in these problems, it would be radical 3, radical 3, radical 3, and I could combine all of them. So I was like, maybe 3 will work, but it didn't, because 6 is not a perfect square when you factor it with 18. So we thought, well, is there another way we could factor it? And Mark came up with, well, what about 2 and 9? 9, and then the 2 just stays put. And then this one, there's nothing you can do with it, and it just comes down. We're pretty much done, except we have a few like terms.
Negative 3 minus. There we go.
That's right, we have 2 radical 3s. Radicals are like x's. As long as they're the same, you can combine them. Now, the 2 is a freak, so it's just going to be by itself.
Hey.
So, what is, now again, let me ask you this. When we, let's say this was negative, let's say this was negative 3x minus 3x. Wouldn't you just do the numbers? You wouldn't like make it negative 6x squared if you were just adding and subtracting. The x's just stay the same. Same thing here. What's negative 3 minus 3?
Radical. So negative 6.
You can do it on the calculator. Negative 3 minus 3.
Is negative 6.
Negative 6. So it's negative 6 radical 3 when you combine these two. Those two are now combined. I had negative 3.
Minus 3 radical 3.
That's right. Minus 3 radical 2. And that's as simple as you can get it. Really? That calculator is gold then. Most calculators won't do that. Although, heck, you know, if you go to the library sometime, type in, hey, can I do radicals on the calculator? Maybe it'll let you. I don't know.
You can also just go to some math thing.com if you should understand.
There you go.
You type it in if you answer it.
If only we could do that on the test. So anyway, negative 6 radical 3 minus 3 radical 2. Boom. Question.
Is it okay if I use my calculator on here? Or do I have to show it?
I'm going to say yes. I can't promise you that like it'll do all, like when we get into 4th roots and 5th roots, I don't know if it'll do that. If it will, then great.
You know you can program these too, right?
Okay then, do it.
Just takes programming.
All right, let's look at the next one. Number 5. Now, darn. Are any of these prime numbers under the radical? No. Darn. So it's not going to give us a big hint like, hey, you want to work down to this. So we're just going to have to look for perfect squares that go in to the numbers 27, 12, and 27. Although, could you combine a like term right off the bat?
27.
That's right.
27.
The two 27s are in common. So don't make yourself do an extra step. Go ahead and combine those. What's negative 2 minus 3 in your calculator?
Negative 5.
So that's negative 5 radical 27. Excellent observation, Tyler. Negative 5 radical 27 minus 2 radical 12. Now we have to get into the reducing of the radicals.
Yeah, both of them have 3 going.
How's the first one going to work?
Be 9 and to be 5.
I'm just going to write it down like you say first. 9 and 3?
9 and 3.
And how's the second one work?
4 and 3.
Now, what makes those particularly convenient, Tyler?
They're both
Schmurfik schmares?
the perfect square.
There we go. That's right. And you're firing on all cylinders today. And what is the square root of 9?
3.
So that's -5 times 3. Radical. Now, you could skip this step, but I want to show everything. Minus 2. What's the square root of 4? 2. Radical 3. So what's -5 times 3 is -15. Radical 3. And then, was that 4? So we're almost done. Are those last two things common? Yeah! So what's -15 minus 4? -19. Radical 3. Sweet! That was awesome. And the whole thing boiled down to that. How may I... Now, someone asked earlier, pause video. I won't even pause the video. I don't even care if the world makes me telling you this. Somebody asked earlier, couldn't you just on a test see which of the answers worked? Yes, you could. If on a test there were 4 options, if you were to punch this whole thing in the calculator, now,
You get a big decimal.
the only thing I would warn you about there, if you punch this whole thing in the calculator, most of your calculators, when you plug them in, if you hit square root, it's going to automatically, boom, open up parentheses. Which means, let's say you're plugging this in. If you did -2 square root of, boom, 27, you'd have to boom it back and close that 27 before you moved on. Otherwise, it's going to take the square root of everything, and it's going to cause it to be wrong. But yeah, you can punch that whole thing in the calculator, and then just see which answer equals that same decimal. Absolutely. You can do that kind of stuff on the ACT, the end of course test, the learning checks, my tests, these quizzes. I encourage that. That is thinking outside the box to answer your question. All right, here we go. What? We just did this. Because I was out of space down here.
Okay.
Okay.
Glad you like code. All right.
All right. All right. Moving on. Move on. Cody, you sticking with me?
Yeah.
Stamming? All right, here we go. Hey, Cody.
Yeah.
Up there. What's the only one we can reduce?
27.
That's right, the 27. And what does it reduce into?
9 and 3.
Awesome. I'm tired of this blue. Let's go with the dark orange. 3.
That's depressing.
That's actually more of a poopy brown, isn't it?
What?
A poopy brown? I don't think Kagan cares. Okay. Hey, Cody. What's the square root of 9? 3?
Those bananas. That's 2 bananas.
And nothing else is going to change. So I'm just going to... So what's 3 times 3, Cody? 9.
Yeah, Tyler.
What's my only like term here, Trey? Somebody wake up, Trey.
Dre.
That's what I said, Dre.
You said Trey.
I said, Dre!
30.
What's my only like term on that bottom row? That's right, radical 3. So I'm going to do 9 radical 3 minus 3 radical 3, which is...
6 radical 3. Never mind. I put it in backwards.
Yeah, that's right. And then plus 3 radical 2. And you're done. Ain't nothing else you can do.
Shebang.
Shabam. Shabam. Sweet. All right. Questions? Moving on. Make sure we get this down because it's part of your quiz grade.
Oh, yeah.
All right, moving on.
Wait up, I'm just writing down the last part.
Yes, sir. I can definitely wait up for that. That is a good reason to wait up. Moving on.
Hey, this one should be easy.
I hope so. Man, you're right. These is easy. When you multiply radicals, we kind of just did that by adding and subtracting radicals. When you multiply radicals, all you have to do are
They all
multiply
simplify.
what's underneath. So what's 6 times 8?
48.
Oh, hold on.
Radical 48.
However's, and that's exactly right. However, we can now reduce this.
12 and 24. Or 4 and
we go
12.
away,
4
dude?
and 12.
Somebody rack your brain.
It's like one number from a
12
perfect
and
square.
I hate school.
12 and 4.
6 and 8.
All right. I heard 12 and 4, I heard 6 and 8. Okay.
4 is a perfect square.
4 is a perfect square, so I'm going to choose 12 and 4. So that'd be square root of 12. I know, I heard a whole lot though. So what's the square root of 4?
2.
Now, is 12 a composite or prime number?
Well, it's a composite.
Yeah, so we have to see if we can do it again. Can 12 break into a perfect square?
3 and 4.
4 and 3.
4 and 3. I'm going to come over here and do that. So that'd be 2 times. And what's the square root of 4? So 2 times 2 is 4 radical 3. And that is your finished product. But you're right. Just multiply what's under the radical and then simplify. Hey, we're almost done, ain't we?
Yeah, got
Get
one more.
radical. How'd you get the radical 4?
We got one more. Big down.
Here?
No, over there. Yeah, there.
So you get how we got here?
Yeah, I get how you got it there and how you got it to 12 and 4, right? But what did you get it at?
What's the square root of 4?
2.
2, radical 12.
Okay.
And then we broke 12 into the same thing.
Hey, number 2 we did on our dome.
That's right. I want to see if anybody would notice that. Okay,
Oh.
so if you did your dom, you've got that one too.
So we at least get some credit.
Last but not
Why
least.
would I say that? That sounds stupid.
Hey,
Yawn.
Yeah. I
Yeah,
hate
that's pretty
that.
annoying, isn't it?
I hate that.
Moving on.
Matter of
I
opinion.
hate that.
Now. All right, we're multiplying. You have to distribute.
No.
Now.
It'd be 3 square root.
Hold it. You're doing my teaching. I mean, you're doing it right, so good job. But so many people are going to do this, be like, oh, that's radical 30. But the 3 is not under a radical. So you just have to combine them into 3 radical 10. Yeah. And then,
multiply the radicals.
which would be
3 radical 20.
radical 20. Can I reduce any of that?
no,
Are you sure?
20 and 10.
no.
10.
3 radical.
The
5.
10 does not, because 5 and
20
2 are not
divided
perfect
by
squares.
5 and 4.
Okay, 2 radical 5.
Are either those perfect squares?
4 is 4 and 5.
No.
20.
Now here's the thing. 10 is composite, but none of its factors, 1 and 10, 2 and 5, none of those are perfect squares. So unfortunately, that guy's done.
But the 20. 4 and 5. 4 and 5 and the 4 is the square root of 2. Oh, yeah.
Oh man.
4 is 2.
We are in a rare form today. Everyone.
That's Junior.
So, what's the square root of 4?
2.
So that'd be 3 radical 10 plus 2 radical 5. And actually, yeah.
Shebang. We should do some homework. Yeah, we should do some homework.
All right.
Hold on. Let's do like number 4,
Will you do that the second?
number 8, and
Let's
number
just do
12.
as much as we can.
Number 2?
I feel like I blow my
You're
You're dumb.
How much I pull out.
Not, we'll just do everyone but the dumb one. See how many people did it. What do you think, Rocky?
What?